Myself, Mr.S.R.Barbade, Assistant Professor, Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. We will discuss the concept called association rule mining, which is heavily used in machine learning. Learning outcome: at the end of this session, students will be able to describe and implement the concept of association rule mining in Python. Contents: we will discuss the association rule mining in 3 steps. First, we will discuss what is association rule mining. Then second, we will discuss a priori algorithm, which is the heart of this association rule mining. Then we will implement this a priori algorithm for association rule mining in Python. So here the association rule mining is a set of transactions. That means we have a set of transactions and we have to find out the rules that will predict the occurrence of an atom based on the occurrences of other atoms in the transaction. So in the right side, if you look at, this is what the transactions, and there are 5 transactions we have considered here, 1 to 5. So in first transaction, the atoms are bread and milk. In second transaction, the atoms are bread, diaper, beer and eggs. Similarly, all 5 transactions have different atoms, and we have to find out the rule that will predict the occurrence of an atom based on the occurrences of other atoms in the transaction. For example, whenever you find here bread, then there is an associated atom called milk is present. Not necessarily in every transaction it is present, but in most of the transactions it is present. For example, bread and milk is there in this first transaction, whereas in second transaction only bread is there, not milk is there. Okay, so we cannot say that always there is an association, but most of the time we look at, for example, transaction ID number 4 and 5, we see there is a bread and milk appearing. That means out of 5 transactions, by just observing we find out that there is an association of bread atom with the milk atom. Not always. Here in transaction number 2, it is bread is there but milk is not there. In transaction number 3, milk is there but bread is not there. So these are isolated transactions, we can say, but these transactions 1, 4 and 5, these are, for example, atom called bread is associated with milk. That's why we say here, given a set of transactions, for example 5 transactions, and we are finding the rules that will predict the occurrence of an atom based on the occurrences of other atoms in the transactions. So this atom is occurred, and this is because the occurrence of bread. Okay, so just by, it is very simple table having only 5 transactions, but if you have, say for example, thousands of transactions in our table and we are asked to find out the atoms which are associated with other atoms in the transaction, then we require some algorithm, and for that we are using a priori algorithm for this. Okay. Second, we will see some here the basic concepts of association rule. Here we have what is given to us is database of transactions. Like in earlier slide, we saw that there were 5 transactions, and second is each transaction is a list of atoms. So we were having, for every transaction there are some atoms present in the list, and having so many transactions in our table, we are going to find out the rule which identifies the occurrence of one atom for the or whenever the occurrence of the another atom is there. And what we are doing is we are finding all rules that correlate the presence of one set of atoms with that of another set of atoms. Like I said earlier, we are finding we have identified by just observing that bread is associated with the milk, not necessarily other association might be present in the transactions. That also we should find out. That means we should find out all rules, not only one rule, all rules that correlate the presence of one set of atoms with that of another set of atoms. Okay, so where it is required, for example, here the 98% of people who purchase tires, for example, this is what used in automobiles. Okay, tires are used, and auto accessories also get automotive services done. So 98% of people who purchase tires, okay, and auto accessories also get automotive services done. That means in addition to purchasing a tire and some other auto accessories, they get their vehicle serviced also. 98% of the people do this. So this is what, there is an association of this getting automotive service in a shop where tires and auto accessories are sold. So this is what common nature of the human being, and that is we have to identify, and based on that we have to give the services, or we should provide the atoms in a shop. Okay. Another applications, if you look at, there are mainly 2 types of applications we find of association rule mining. One is in maintenance agreement, like here we have seen what the store should do to boost maintenance agreement sales. That means if you are doing some purchases of one atom, then you are going to purchase some other atoms in the store also. So that maintenance item, for example. So this is one application of the association rule mining. The second is home electronics, like for example, wherever we keep bread, it is beneficial, or it is what we can say wise to keep the milk also, so that these 2 atoms are mainly associated with each other. So the person who is going to purchase a bread, it is 98% possibility that he or she purchases the milk. So that's why home electronics, we see what other products should be stored, stocks up, like for example, if you are purchasing electrical kettle, then possibility is that the person purchases the tea and sugar also. So here we should keep this in mind. There are many factors we should consider. For example, item set, a collection of 1 or more items like milk, bread. Then K item sets, an item set that contains K atoms. So that table here, for example, 5 atoms are present. K value is here 5. Support frequency of occurrence of an atom set. For example, this milk, bread and diaper, these 3 products are available at 2 times here, where it is, just look at milk, bread and diaper here, and milk, bread, diaper. So it is that means support count is 2 for milk, bread and diaper. And then what is support itself? Fraction of transaction that contain item set. Here out of 5 transactions, 2 transactions are there which contains milk, bread and diaper. Okay, so 2 by 5 is the support, and here support count is just 2. And frequent item set, and in item set whose support is greater than or equal to mean sub threshold, that means minimum support we can say. So that is called frequent item set. So frequent item set generation is still a computationally expensive task, but using this a priori algorithm we can implement with less computational complexity. So this is what a priori algorithm we are going to see now, which reduces the number of what you can say operations to generate the list of rules. Given d items, for example, where the 2 raised to d possible candidate item sets, a priori principle holds due to the following property of the support measure. For example, there are 2 items x and y, where x belongs to y. That means here x is a subset of y. Then support of x is always greater than support of y. Okay, x is a subset of y. That means support of x is always greater than support of y. So here we can say that support of an item set never exceeds the support of its subset. So here we have item set, and bread item is available in 4 times, coke is available 2 times, milk is available 4 times. Like this is with 1 item set, this is with 2 item set, and here we are having for example milk and bread 3 times, milk and beer 2 times. So this is what we are getting is the minimum support is equal to 3. Can you list the additional applications of associative rule mining? You pause the video and answer the question. Here we can see many applications, like in grocery store, how the items are managed on the shelf can be based on the rules whatever we generate. For example, if there are shoes, the shoe polish we make available on that same thing. So this is what the algorithm of a priori algorithm. Let k equal to 1, then generate frequent item set of length 1 first, then repeat this up to k plus 1. So generate a length k plus 1 candidate and prune this and count the number of each candidate by scanning the database and eliminate candidate infrequent. So this way a priori algorithm is made. Now Python implementation of a priori algorithm is shown here. For this what we required is mainly NumPy is also required, Matplotlib is required, Panda is required, but we have to import this a priori algorithm from a priori, so that must be present. And then we use the data file, that is data.csv file, which contains the transactions with item list. Then we apply this a priori algorithm on the data list and we generate the rules. And if you look at the rules, for example, here the rule is what? Frozen vegetables like milk, frozen vegetables, milk and olive oil. So this is what the association between these 3 items. Olive oil, whenever is purchased, the frozen vegetables and milk is also purchased. So this way we can generate the rules. References: Machine Learning by Tom Mischel and Foundations of Machine Learning by Mehrer Mohri. Thank you.